When was it in your career that you began to see the inseparability of molecules and mind and consciousness, or where was the turning point for you that actually, in a way, solidified your point of view that reductionism and mechanistic frameworks don't work?
Well, I was doing research at Cambridge for my PhD in plant development. And I worked on plants because I didn't want to spend my career killing animals, and research on animals basically involves killing them all the time.
Yes.
So I was working on how the main plant hormone, auxin, is produced, and I discovered it's made by dying cells within plants. The cells that become the wood cells in plants, they are dead empty tubes that conduct water there like little pipes. In order to become wood cells, they die. And as they die, as the proteins break down, they give off a whole range of breakdown products, one of which is the main hormone that gives more life. So here, for me, this was very exciting, that the key to life in plants is death within them, that death and life
makes life possible.
Exactly. So this was a remarkable finding. And I then went on to work out the mechanism of polar auxin transport. This hormone is transported around the plant towards the roots in a polar way, from shoot to root. And when that had happened, this was a major breakthrough, and this is kind of textbook stuff now, the polar auxin transport thing. I then realized that the very same auxin, same hormone, is present in all plants, in all parts of the same plant, you know, in petals of a rose and the leaves of the rose and the spines of the rose. Yet they all have different shapes. So the attempt to explain all this shape and form in terms of chemicals seemed to me doomed to failure, because this one-size-fits-all chemical couldn't possibly explain the diversity of forms. So I got interested in an idea that was already there in biology since the 1920s, morphogenetic fields, invisible shaping fields. These give a kind of holistic patterning of plants and animals. There's leaf fields that shape leaves, petal fields that shape petals, and so on. These fields have a kind of goal. They draw things towards an attractor, a goal. But at this stage I wasn't, this is mind-like, but at this stage I wasn't particularly concerned with consciousness. I was working on plant form and came to the idea it must be holistically organised. Then I realised the same applies to animal form. Then I realised that the organisation of the nervous system in animals must depend on fields, similar to these fields. Then I thought, how do these fields work and how are they inherited? I then came up with the idea, when I was working in Cambridge as a research fellow, of morphic resonance, a kind of memory in living organisms that's carried through these fields. And this really changed everything. I suddenly had a hypothesis that could predict a lot of new phenomena that I could test, and which cast a whole new light on the way biology and minds work.
Let's talk a little bit about these fields of morphic resonance. They're not in the physical realm, they're not even at the level of energy, they're like platonic forms, would you say?
Oh, no, they're not platonic forms. The problem with platonic forms is that they're outside space and time. They don't evolve.
Oh, so they are in space-time.
Oh, they are in space and time. So my morphic field is within and around me, and it's within my body and around my body, like a magnetic field is within and around a magnet.
But the morphic field is not an electromagnetic field.
No, it's a different kind of field. You see, we've already got several kinds of field in nature. They're all different. Gravitational fields, which hold us down now. We're not floating around because of this invisible field.
Correct.
Electromagnetic fields, light, radio waves, and so forth. In quantum theory, a whole series of fields, electron fields, proton fields, neutron fields, each kind of
particle has
its own kind of field. There's dozens of fields. And what I'm suggesting is that it's not just in quantum phenomena at the microscopic level that there are these fields. There are fields for each kind of molecule, for each kind of cell, for each kind of tissue, for each kind of animal and plant. And that these fields are organising fields that are in space and time, and they have a memory, they depend on what's happened before. So the way a palm tree grows depends on the way previous palms of that species have grown.
I'm just trying to come to grips with the morphic field as it relates to what we ordinarily know in science as these other fields, the electromagnetic fields and so on. So would you say that these morphic fields are like possibility waves, or before they actually become measurable?
Well, the point is all fields are measured through their effects.
That's
I mean,
right.
this room's full of the gravitational field.
Correct.
We measure it not through an electric meter or anything, we measure it through its gravitational effect, the way it affects a pendulum swinging, for example, or the way it pulls things towards the Earth. So all fields are measured through their effects. All of them are invisible. This room is full of the electromagnetic field, and we're seeing through it, but there's a lot of it we're not seeing through because there's infrared, ultraviolet, X-rays and so forth. So all fields are known through their effects, and what morphic fields do is create a kind of form or organizational pattern. They attract developing systems towards what I call morphic attractors. They're fields of possibility that influence quantum and other possibilities. Everything is indeterminate in nature. It could do one thing, it could do another. And if you have a higher level of organization that makes something, it could do that, it could do that, this higher level, push it that way and not that way, then of organization imposing form. So that's how morphic fields work. And they work through, the form they have depends on this memory. So I'm not saying that they're outside space and time. They're inside space and time. They're physical, they're part of nature, but they're just not part of existing physics, because existing physics hasn't yet taken this kind of field on board. But when it does, then we'll expand our field theories. We've already got all these other kinds of fields.